thing, and because usually people have a hard time remembering things that span more than an hour, I'll try to be more interactive, and so it will be like more fun for you. First of all, I'd like to start out with a question, or a set of questions to be precise. Just by a show of hands, how many of you are front-end developers, or think that you are front-end developers? That's super fine. I mean, I'm not judging. That's incredibly okay. It was not a joke. So, back-end developers. Who's the back-end developer? And who's a unicorn? Who thinks he's amazing and does everything? There we have you. Amazing. So, okay, so we have a mixed audience. That's actually pretty interesting. I was thinking that most of you guys were going to be focused on Node and backend and maybe a bit of DevOps or maybe a bit of both. So I think it's going to be pretty fun. Based on that you know pretty much, I think, enough for the backend stuff. I'm not going to be too basic with the presentation, so I'm going to skip a bunch of stuff that's not relevant. But to begin, and as Norby said, so you don't think that he found me on the street somewhere, I actually do this stuff, as in I work as a developer advocate at a software as a service startup that's founded in Estonia. We do serverless observability. So if you want to check this out, you can just Google this. And I've been teaching people to code for the last couple of years, so that kind of makes sense why I transitioned from being a developer into being an evangelist or a developer advocate. And the reason because that happened is because I write a lot of educational content. So you may have read some of my Node stuff on Medium. If you have not, doesn't matter. You can check it out. And I authored a course, a video course about serverless and about JavaScript. And that will be actually part of a free giveaway at the end. I'm going to just randomly pick somebody from the audience to get a free coupon for that course. And who's going to be most active with the questions, I'm going to give away a couple of free tiers and trials for Dashbird, the serverless thing that they paid me to come here. So I have to give those away as well. But yeah, you get the point. So yeah, let's jump in. The reason why I'm actually doing this isn't to act smart, that serverless is cool and that containers are a buzzword. To be honest, both of the words are very buzzwordy, and if somebody says, I do containers and Docker and I do Kubernetes and then writes it with K8S instead of writing just the fucking word Kubernetes, it's not that complicated. Same with serverless, it's not that complicated. Just the words are pretty stupid. Once you get around the stupidness of the words, it's going to be super fine. That's what I want to talk about. I don't want to position ourselves as guys who do containers or serverless, or we want to pick what's best of both sides. And that's what I want to say. I want to explain to you when to choose what, and not to differentiate by, I like this more. Just use what's best for the problem, right? That's what I want to teach you. And no, there will be no votes in the presentation. So, just a short agenda, like maybe 2 minutes to go through what we will be talking about, so you don't get lost, because there are plenty of slides. We will say what are the basics of containers. So what are containers, what they do, how they became a thing, why they are a thing, and why people use them. We will see why they are good and why they are bad, and we will see valid use cases of why and when you can use them. We will also see how complicated it is to deploy a containerized application. You will figure out that it isn't that straightforward. There are at least 4 steps in you deploying an application that is containerized. I'm going to show an example for Node.js because I do Node.js, and hopefully you do too. I hope there's nobody that does PHP here, because if you do, I'm very sorry. No, PHP is fine. So, apart from containers, we're going to do a bit about serverless. I'm going to explain the differences between the two, and I'm going to explain why it's called serverless, and it's not because there are no servers, and I mean, let's just not be stupid. There are servers, of course. And we're going to go through the same process as with the containers. We're going to explain the pros and cons and the use cases and why you should use this in a given use case. Finally, we'll also check the deployment cycle and how much simpler it is to deploy a serverless application than it is to deploy a containerized application. Of course, this simplicity is very relative based on your experience. If you're maybe experienced with Linux, you're going to have no issue doing containers. If you're maybe only starting out and do only React, you're going to have absolutely no issue deploying a serverless app whilst kind of having a hard time doing a deployment for a containerized app. But it's all relative. I'm going to show you the differences. So to start out, is there anybody in the room that is really focused and knows about containers through and through, that does a deployment with containers on Kubernetes, on Docker, or whatever, in production in this room? By a show of hands. If no, amazing! You're going to learn something new today. First of all, a container as a container. View it as an isolated, stateless environment. It's a box, and nothing can get out of that box. We put stuff in, and that's isolated. That's it. That's okay, right? So the way I usually explain this is, everybody knows what the virtual machine is. I mean, in school, college, everybody teaches about virtual machines. If somebody doesn't know what the virtual machine is, please, don't be shy. Okay, everybody, good. So a container is basically a virtual machine, but not really. And why is that? Why is that? Because a container, this is a visual representation. A container uses the operating system of the host. It uses the same kernel as the host, meaning that it quite literally has these invisible walls in between the applications, or actually the containers. So it uses the same kernel, whilst the virtual machine has its own operating system, meaning that the virtual machine with a simple application can be maybe a gigabyte in size, whilst the container can be 50 megabytes. So containers are much faster and much easier to use. So we got that part now, okay? Make sense? Awesome. Just to mention, who has ever tried to do a local virtual machine on their own, like local machine, and had the error of Hyper-V something something error something? Everybody, I mean, seriously, I mean, and that's because the Hyper-V thing on Windows is the hypervisor. It's a software that actually creates the virtual machine or allocates the actual CPU, memory, etc. of the virtual machine on the host machine. And it's so complicated and unnecessary. We should just use containers because it's 2018. So, I've said amazing things about containers so far, but we have to figure out a bunch of things about containers for production. Containers as containers, they do not auto-scale, meaning that you have to be the one that's going to set up the scaling of the production environment. You can use provider-specific tooling, as in AWS has auto-scale service something because they have a bunch of services that end with service. And they do it, it's okay. But you still have to set it up yourself. And that's an overhead. And in comparison to serverless and a bunch of other things, containers are much harder to deploy because there's a cycle of how you build a container and deploy it and make sure it's all updated, etc. And if you're somebody who's a front-end developer or a back-end developer that has nothing to do with Linux, it's going to be very hard to understand what's going on. So the curve of learning it is pretty steep. You have to learn what Docker is and what the hypervisor is and what kernel is and all those funky words that people who live with their mother in their basement know because Linux. But yeah, there are many complex parts of using Docker, and that's why it's hard to learn. And then, apart from that, if somebody says Kubernetes, so it's just, no. And of course, the last part that you tell your boss when you do containers is because it's more expensive than doing serverless. So that's something you have to take into consideration if you're doing maybe a startup or you're actually the one that's responsible for the money. So that's the last con I can confidently say about containers. But not everything is that bad. When you think about it, if you know what you're doing, when you have full control, it's amazing. You can do whatever you want with your containers. You can do whatever you want, period, like end. And that's amazing for somebody who knows what he's doing, but that's also a double-edged sword, so you have to be careful. But if you know what you're doing, you can actually scale it infinitely. I mean, infinitely, theoretically infinitely, but you're limited to your provider. I mean, AWS has, I think, 1,000 EC2 machines are allowed. So you can theoretically scale to 1,000 EC2 machines with absolutely no problem. And that's much, much higher than you can do with serverless. Of course, because it is very established in the community and people do containers and build applications for containers and microservices for the last 2 years, the tooling provided is amazing. You have everything provided for you. You just quite literally add like a Lego brick. I want monitoring, I want this, I want logs, I want that. Everything is provided for you, so it's very easy. And as a dev team, it's incredibly simple to have a unified environment for your whole team because Docker creates that for you. No matter the host operating system, Docker itself, as in the containers, will always be the same environment. So it will never happen that somebody from your team says it works on my machine because seriously, who has never said that? Everybody says it works on my machine, go fuck yourself. So seriously. So that's a very good thing with containers. It's a unified environment and everybody's on the same page. So if you think about this, if you think about both the pros and cons, what are the use cases you can use? Well, obviously monoliths, obviously applications you already have in production that are pretty old. You can take that chunk of monolith, put it in a container, and that's going to work fine. And then you can gradually figure out, okay, maybe I should just remove this one and create a microservice and then create another and then gradually build upon that. That's a very nice use case you can think about if you want to do it yourself. Of course, the standard stuff, as in web APIs, anything that's long running, those are all things that you can use containers, and they will be much more effective than with something like serverless. Of course, if there's anybody here who knows data science or machine learning or AI, dude, you are amazing. I don't know how you do it. It's so hard. I tried it once and I went home crying. So data science is good for this because it's CPU intensive and because you're actually using all the resources of the machine all the time. That's why this is amazing, because you're paying for it all the time. So why not use it all? Okay, that's pretty much it. And I want to show you now, based on everything we know so far. We know the basics of why it's okay to use containers, why it's good, why it's not good, the use cases of when it's okay. You have covered the basics. So now let's figure out, let's say you're a DevOps engineer and you want to deploy a Node.js application, a container, to a Kubernetes cluster on AWS. Now, these are all really long words and scary once you've never done it before. But when you think about it, it can all be broken down in a couple of steps. Now, the first step is you actually have to build the container itself. So you have to take the app, build the environment, and create a thing out of it. Build the box. And that's pretty simple with Docker. Has anybody used Docker before? Good, you already know. So you install Docker, and that's pretty much just a tool on the command line that lets you create containers. And then, once you have your tool there, okay, let's build a Node app. Super simple Node app, because this is a demo. Not a real demo, because time. And then, once you have your Node app, you build something, or you write something called a Docker file. Now, the Docker file itself is only a representation of how you want your container to look, what you want in it, what you want to run in it, etc. So, this file itself will only take the actual image or the Linux instance you want to run in the container, and this is just a Node version of Alpine. It's super simple, we'll only have Node installed, that's all we need. And it will create a work directory, paste in the package files, so you can install all the modules you have, and then it will copy over the app itself. What's key here is that it exposes one port, and it runs one command once the container is created. So, when I run this, it will run the app, the actual Node app, inside a container. Simple. It is simple, but there are so many steps to it, because once I have the actual image built, I have to push it somewhere. And then you think, okay, so pushing, maybe, I know Git, okay, everybody knows Git, so where do I push this thing? Well, once you build it, you have to push it to something called a repository, a container repository. That's where the images you built of your applications are stored. And the reason you have to push it there is because you kind of have to pull it to your server from that repository. You're not going to push it to your server from your machine, because that would be just stupid, because you're not the only developer in your team. There are like 10 of you, and you have to have the same versions of everything, and you have to make sure that the environments all match. And there are just tons of complications there. But okay, let's say everything is fine, you push it, and then it's like, oh, okay, so I have my container, finally. What now? I have to build the cluster. And luckily, there's a tool called KOPS, K-O-P-S. It's an open source tool you can find on GitHub. It's quite literally a CLI for creating Kubernetes clusters. And by installing it and running this huge set of commands, you will have a Kubernetes cluster installed. Now, this will in real life take a while, so let's just imagine that we're really good at it. But once we have the cluster installed, then we can actually deploy our image. Then we can deploy our application we built and we sent to Docker Hub. I mean, it is pretty tiring when you think about it. But to install it, or to deploy it, you actually need to install another tool called kubectl. And this is another CLI tool that's the interaction layer between your machine or your terminal and the actual cluster, the Kubernetes cluster you just created. So through this command line, you can check your resources in your cluster. And then, once you have your cluster installed and you have your tool installed and a way of interacting with the cluster itself, then you need to create files called a deployment and a service. Now, these YAML files are simple configuration files for Kubernetes. And the way they work is that you define which image you want to run, you define the ports you're running it on, and you're defining something very cool called a rolling update strategy. Now, does somebody have any idea what the rolling update does? And it's, maybe a rolling update. It's basically a rolling update. So if you have any changes in production you want to push, your users will never face any downtime. And think about the fact that it's there by default. So even if you have like no users or maybe 10 users a day, you can still build this with maybe a single or 2 machine cluster, and you're never going to have downtime ever. How cool is that? And you're basically doing nothing. This is super simple. So, okay, I'm digressing. Let's get back. So what you're doing is you're creating a deployment for the actual container itself, what image you want, which ports, etc. But the service is the magic. It exposes our containers from the cluster to the outside world. And because of how KOPS works in mysterious ways, it will create, on AWS if you choose, it will create both the load balancers that's dedicated, it will create everything you need, all the security mumbo jumbo that nobody wants to know except for the Linux guys, who are not here thankfully because they would throw stuff at me. So it does everything for you. It creates all the load balancers, all the instances, all the security, VPNs and whatever cool words people use. And what's the key point here is that you use this kubectl CLI to run these files against your Kubernetes cluster. So your cluster itself will take these files, create the resources, and your containers will be running on your cluster. So, what do we get in the end after all these steps? This is something that's default for Kubernetes. It's their main admin panel, we'll call it. And here you can see all your containers and everything you have in your cluster. And this is by default. And this is by default because, Google made Kubernetes. So stuff is gonna work because it's pretty awesome. And what else is cool is that you get this almost by default itself. You can have monitoring and logging and whatever you need by default just by adding one more container into your cluster. That's going to do this for you. That's because the environment is like that, and the actual ecosystem is like that. It's so mature that you have everything like Lego bricks. I want this one, I want this one, and it just works. But it works because it's mature, and it's very hard to learn everything. Because if you figure it out, step 4 is to have this. So you have to learn a bunch of stuff before you get to this, right? And that's both good because, I mean, you're not going to get fired because you know a bunch of stuff. But then again, I mean, who's going to want to do this? I mean, nobody really wants to learn this. I mean, who's a DevOps engineer? Is there anybody who... No, like, that's my point. Nobody likes this. You want to code, like, why would you... Seriously. But yeah, after all of this, we have finally deployed a Node.js container to a Kubernetes cluster. And I'll be honest, this is the easy way. I'm not even kidding. This is the easiest way possible you can have a running cluster on AWS. Like, if you want to do it any other way, it's going to be twice as hard and twice as painful. So imagine me learning it the hard way. It was not fun. Okay, let's finally throw away the container stuff. Let's talk about serverless for a minute and why it's so much better in some things and why it kind of sucks at some other. But first of all, I want to demystify some things. The name serverless, has anybody heard the word and then just kind of wanted to learn about it, but then was like, what the hell? And they just gave up? I mean, seriously. I was the same. I heard the word and it was amazing, then I Googled it, and then like 11 different things popped up, and I was like, no! And that was my life back then. But then when I actually sat down and started learning it, the key things that come into mind is that the actual compute of serverless, the actual code that's run, is just something we call function as a service. Is that we have a function somewhere that has our code, it runs, we pay for the time it runs, and it returns some value. That's it. We don't care about where it's running, we don't care about the infrastructure, we don't care about anything. We just want our piece of code to run, to execute, to return a value, and we'll be on our way. And that's a service called function as a service, or FaaS. And if you know about AWS Lambda, or Google Cloud Functions, or Azure Functions, that's all the same principle, function as a service. Right? Now, the actual myth here is that people tend to think that FaaS is the only thing that's based on serverless, or the only serverless thing is FaaS. It's not really. Everything that we have that are event-based systems for running code are viewed as serverless. So if you have ever built a static website and hosted it on S3 on AWS, that's serverless, because you have a website, but it's not on a server, it's in an S3 bucket. Have you ever used SNS or SQS on AWS? Yes, to trigger different things. That's also serverless, but you haven't thought about it because why would you? So that's my point here. Serverless as a thing is event-based. So anything you're doing that's event-based, that's triggering different things, interacting without you managing anything, is basically serverless. So that's the point I wanted to make, because serverless is a name that tells us to not care about the servers, because we only care about the code. So the infrastructure is irrelevant. We care about the code, and we care about our business logic. We care about the code we write to actually bring value to the company, or to bring value to our startup, or whatever we're doing. That's the key focus. And of course, abstracting away the infrastructure is very cool for somebody who doesn't know Linux, who's not a backend dev, who's maybe a front-end dev, and wants to build his own startup. That's amazing, because he doesn't care about anything except for the code. It makes it all easier. Now, not everything is that bright with serverless when you think about it, because there are some cons, as in defined limits. So there is only that much it can handle, even though it scales by itself, as in it scales on the user base you have, it still won't scale indefinitely. So that's the thing you have to think about. And because it doesn't scale indefinitely, you can risk overloading it. Meaning you can only have a set number of concurrent requests before it dies out. But the thing is that, who wants to guess what's the limit of concurrent requests by default it can handle?
5K?
1,000. So 1K. That's, I mean, who has 1,000 concurrent requests? I mean, unless you're like a telecom company or something. So it's still pretty okay. If you want to get it boosted up, if you are like T-Com or some crazy company, you're most likely just gonna call AWS and they're gonna boost it for you. So if you want more, you can get more. But the actual bad part of it that we can't really circumvent is that the built-in solutions for observability and latency are bad. They are very bad. As in, whatever provider you choose is pretty horrible, except for Azure, because they have the Azure Functions Monitoring built in, and that's okay-ish. But still, everything else you choose is just horrible, because you have no idea what's going on. The whole system you have is so distributed that you don't have any overview. That's a very bad thing. Another bad thing is latency, because sometimes it can be pretty horrible because of something called cold starts, but not to go into more detail there, we can talk about that after because it's already running late. But let's move on. But the good things about it is that you only pay for how much you use, so you can actually run a decent sized website and pay maybe $10, whilst with containers you pay like 100 or something. So based on what you're using, the cost can be almost none. What's also good is you don't have any maintenance, so all your engineers in your team are going to be writing code instead of writing the DevOps pipeline, CI/CD, Travis, whatever. What else is, it's very easy to deploy, and you'll see that in the demo section after this. It's quite literally one command to deploy everything, and everything gets created. Super simple. What's also cool in the end to mention is that it does auto-scale, and that's very nice because you don't have to worry about your users' downtime. We basically never have that downtime, and by default, and it auto-scales by default, so you don't worry at all. And of course, if you're a startup, you're going to be worrying about time to market, and because this is so simple to deploy, your time to market is amazing. Okay. So, mentioning use cases now, the coolest and the most useful things you can run with serverless are, of course, web APIs. You can also do data processing, because that's something you actually trigger and forget. You don't really want to care about it, you just want to trigger it, do some processing of some image, some data, and return it back into a database or whatever. So that's a really cool concept. You can also use them for pretty much any short running process you have. That's ideal for functions or for FAS, because the cap on a function execution is 5 minutes. So if you have something running more than 5 minutes, some maybe data science model or something, just use a container. It's much easier. What else is, it's ideal for periodic processing, as in cron jobs, because you can set literally time stamps or whatever, or like time limits of when you want something to run, and that function will execute only by those like, time execution events or whatever we want to call them. So that's a very cool thing you can do as well. Also, chatbots. If you like chatbots, use this. It's amazing. Okay, so you remember the 4-step thing we did with Kubernetes and the containers? Well, using it with serverless is only 2 steps, and you'll figure out now why I like it so much. The only thing you need is to install one NPM module that's called Serverless, and it's just a CLI tool for building your whole project and sending it off, deploying it to the provider. In this example, we'll also use a module called Serverless HTTP, because it just gives us a really nice way of writing Express and deploying an Express application into a function, because we're already used to Express, everybody knows Express. So comparing the 2 applications we had, the Docker one and the serverless one, it's pretty much the same. Looks exactly the same, behaves exactly the same. So the only difference is that the YAML file for serverless looks like this, meaning the serverless framework wants us to create a YAML file for defining our resources. And it's pretty simple. We only have the simple provider section where we have the AWS provider. We can set Google Cloud, we can set Azure, whatever. We set the regions, we set the basic variables we want. And then in the function section, we define which function we want to deploy. And because we want to deploy the server function that we have over there, we point it to the handler. We connect events to it, as in HTTP events, meaning that we want only HTTP events to trigger this server function. Does this make sense? Pretty simple. Now, when you think about it, That's all to it. Once you have this configured, you run one command. It turns the serverless YAML file into CloudFormation stack, deploys that to AWS, packages the code, deploys that to S3, puts the code into the Lambda, and that's it. You just press one command and it does everything. So you don't have to worry about anything. You just deploy it and it works. And what do we get now? We get a distributed system, meaning that we don't really know what's going on. So if something breaks, we kind of have to figure out on our own what broke and how it broke and why it broke. And by my experience, it's usually a user or a client or an owner shouting through the phone. So that's an issue. But you can solve it with built-in tools. The tooling is not really there yet. You can use third-party tools as Dashbird or IOPipe or Datadog or Sentry or whatever you want to use based on what your preferences is. But use. But yeah, the basic thing is that with this tool you have the same thing as you have with Grafana. If you're used to Grafana or you're used to anything that you have done so far, you're going to be used to this. And that's pretty much the point we wanted to do. Just make it something that people want to use because they're already used to it. But this is the main issue I want you to take away from this, is that if you want stable stuff, if you want to run hard, heavy-duty computations and serve millions of users, go for Kubernetes, go for the containers. If you know what you're doing, go for containers. If you're still not there yet, build it serverless first. See how that goes. If that starts breaking on you, if you can't keep up, then you can start migrating stuff over. Or maybe stuff that is heavy duty, as in hard computation. Or maybe database interactions or whatever. Move that over from serverless to a container. That's my key takeaway I want you to remember here. But as you can see, the steps to deploying a serverless app were significantly shorter than with the Kubernetes part and with the container part. So hopefully you'll give it a try. And let me know if you liked it, if you didn't. But at the end, the verdict I want to say is that you have flexibility and you have control when you're using containers. And you can migrate stuff that's already legacy, as in monoliths or legacy VM deployments, whatever. You can migrate that over painlessly, so that's fine. If you're a boss, that's you. But if you want to use serverless, use it because it's very fast to deploy and develop. It auto-scales by itself, so you can be one dev and build a product by yourself, and it can be amazing. So think about that a bit. And of course, because you're that one dev that doesn't have a product yet, but maybe wants to start a startup, it doesn't cost anything to get started. So that's also a benefit.